Hello, you are welcome to another live mathematics class with Mr Olukorede. I'm super excited that you are here today. Today we are going to be looking at another interesting topic. So we'll be diving into logarithms. Now this topic is the first topic you are going to be taught if you are in SS2. If you just gain promotion to SS2, so that's going to be the first topic you are going to be taught. And don't forget, in SS1, you have been introduced to logarithms. So now before we start, I want you to tap your like button and also share this video with your friends. Alright, now let's start with our definition of logarithm. Now what do we call logarithm? Logarithm of a number to a given base is the power to which the base must be raised to give the number. Wow, now that is the definition. It looks confusing. Now let's look at an example. If you have 1000, 1000 is a number which can also be expressed as 10 raised to the power of 3. Now, what I just defined now, I said logarithm of a number. Let's assume that the number is 1000. So logarithm of a number to a given base, the base should be 10. So logarithm of 1000 to base 10 is the power to which 10 must raise to give 1000. So what must 10 raise to give 1000? That is 3. So logarithm of 1000 is 3. So I can write as logarithm of 100 to base of 10 is 3. So logarithm of a number to a given base, which is base 10, is the power to which this 10 must raise to give 1000. So the power to which 10 must raise to give 1000 is 3. So that means logarithm of 1000 is what? Is 3. So let's look at another number. If you have 100, what's going to be the logarithm of 100? So 100 is the same thing as 10 raised to the power of 2. So logarithm of a number 100 to base 10 is the power to which this 10 must raise to give 100. So I will ask myself, what must 10 raise to give 100? So 10 must raise to 2. So that is the answer. So logarithm of 100 to base 10 is 2. So we can now generalize now, since we have looked at a particular case. Now if we have a number n which is equals to b raised to the power of p. Alright, so if you have this kind of number which can be expressed in index form, b raised to the power of p, then logarithm of the number n to a given base b is p. Okay, so if we have a number which is equals to b raised to the power of p, so then we can say logarithm of this number n to base b is the power p. Alright, now this relationship, we are going to be making use of it in solving some logarithmic equation. Alright, now let's look at this example. Find the values of x in the following equations. So the first one we have is log 16 base 2 equals to x. So we want to get x. Now look at it, the first one, we have log 16 base 2 equals to x. So how do you do this? Now I want us to look at this relationship. Now when you have a logarithm of n to base b, the answer is p. So now you can change this logarithmic equation back to initial equation, this initial equation. So all you just need to do is this base, move it down here and take away the log and you write the n. Hope you get that. So this can be changed to this by taking away this log. This base we have here, bring it here, and the n, you write n alone. Alright, so we are going to do that here. So the base we have here is 2, so it moves here. So we have 16 equals to 2 raised to the power of x. Hope you get that. So we have changed logarithmic equation to indicial equation. So we can now solve it now. So we have 16 to be 2 raised to the power of 4 equals to 2 raised to the power of x, because 16 is the same thing as 2 raised to the power of 4. Hope you know that when you multiply 2 4 times, you are going to have 16. So now, since the bases are equal, so you can equate the power. So you say therefore x equals to 4. X is 4. So that is the answer to the first question. Now the second question, we have log of 125 base 5 equals to x. We just follow the same routine. Now the base moves here and we throw the log away. So now we have 125 equals to, the base comes here, we have 5 raised to the power of x. Hope you get that. So now you express this one in index form. This is a multiple of 5. That's 5 raised to the power of 3. So we have 5 raised to the power of 3 equals to 5 raised to the power of x. Alright, you can see now the bases are equal, so you equate the powers. So you say therefore x equals to 3. So that's the answer to the second question. Now let's move to the third one. Log of 81 base x equals to 4. Log of 81 base x equals to 4. Now look at this. So now the base moves here. So we now have 81 equals to x raised to the power of 4. And the next thing is to express this in index form. So what is 81 in index form? So that's going to be 3 raised to the power of 4. 3 raised to the power of 4 equals to x raised to the power of 4. You know, when you say 3 times 3, that is 9. 9 times 3, that is 27. And 27 times 3, that's 81. So you have multiplied 3 4 times, so to have this. So now, since the powers are equal, so you equate the base. So we have therefore x equals to 3. So that is the answer to the third one. Now let's look at the last one. Number 4. We have log of 144 base x equals to 2. Just like we did the other time. So you just move this one here. So we have 144 equals to x raised to the power of 2. Alright, you get that? Now this can be expressed as 12 raised to the power of 2, because 12 times 12 is 144. So we have 12 raised to the power of 2 equals to x raised to the power of 2. As you can see, the powers are equal. Then you can go ahead and equate the base. So we have therefore x equals to 12. Alright, so this is the answer to the last one. Now let us look at the next example, example 2. Now this is the second example. Find the unknown in the following. So we have log of square root of 32 base 2 equals to x. So how do we do that? The first one, we have log of square root of 32 base 2 equals to x. Now you don't need to be afraid of these square roots. It's very easy. Whenever you have square roots of x, you just express it as x raised to the power of 1 over 2. If you have cube roots of x, that is going to be what? X raised to the power of 1 over 3. Hope you get that. So we have fourth root of x. What will that one give you? X raised to the power of 1 over 4. Alright, so now that is what we are going to do here now. So this equation turns to 32 raised to the power of 1 over 2 base 2 equals to x. Hope you get that. So now the next thing now is move this base to this side so that this log moves away. So we have 32 raised to the power of 1 over 2 equals to 2 raised to the power of x. Alright, So now, the next thing is to express this in index form. 32 in index form, that is going to be 2 raised to the power of 5 raised to the power of 1 over 2 equals to 2 raised to the power of x. Right? So when you multiply 2 in 5 places, right, you are going to have 32. So now, 5 will multiply half. So we have 2 raised to the power of 5 over 2 equals to 2 raised to the power of x. As you can see, the bases are equal. 2 is equals to 2. Then we can equate the powers. So we have, therefore, x equals to 5 over 2. And 5 over 2 can also be written as 2 whole number 1 over 2. 2 goes in 5 is 2. Remainder 1 over the denominator. So this is going to be the answer to the first question. You can see it's very simple. Now let us look at the second one. Now let's look at the second question. The second question, we have log of 1 over 16 base 2 equals to x. Second question, log 1 over 16 base 2 equals to x. Now this base comes here. So we have 1 over 16 equals to 2 raised to the power of x. Alright, now the next thing is to express this in index form. So we have 1 over 2 raised to the power of 4 equals to 2 raised to the power of x. Alright, now this reciprocal, we give this 4 a negative. So this expression turns to 2 raised to the power of minus 4 equals to 2 raised to the power of x. Now, you must be familiar with this in indices. Whenever you have x raised to the power of minus n, it will give you 1 over x raised to the power of n. Alright, now you can see now that the bases are equal. So you can therefore conclude that x equals to what? Minus 4. So that's going to be the answer. Alright, now let's look at the next question. The third question is this: logarithm of cube root of x base 6 equals to 1. Now the first thing to do is to move this base. You move it here. And this log leaves. So we have cube root of x equals to 6 raised to the power of 1. Okay? So now you express this as x raised to the power of 1 over 3, okay, equals to 6. Now, the next thing is to take cube of both sides. So you multiply the power of this by 3 and this by 3. So you have x raised to the power of 1 over 3 raised to the power of 3 equals to 6 raised to the power of 3. Okay, so now once this multiply this, so 3 cancel 3, so we have x equals to, now 6 raised to the power of 3, 216, so 216. So that is going to be the value of x. So x is 216. Now let us look at the last question. Minus 2 equals to log of 0.01 base x. Now the first thing is to move this base to this side so that this log leaves. So we have x raised to the power of minus 2 equals to 0.01. Okay? Now the next thing is to express this decimal in fraction. So what's going to be the fraction of 0.01? That is 1 over 100. So we have x raised to the power of minus 2 equals to 1 over 100. Okay? Now, the next thing is to express this 100 in index form. The index form of 100 is 10 raised to the power of 2. So we have x raised to the power of minus 2 equals to 1 over 10 raised to the power of 2. Okay, so now we have x raised to the power of minus 2 equals to, now this reciprocal gives these two negative. So we now have 10 raised to the power of minus 2. Okay, now when you look at this equation, you see that the powers are equal. So then you can equate the base. We now say therefore x equals to 10. So that is going to be the answer to the last question. So I'm going to give you something similar to this. So I want you to try it and let me have your answer in the comment section. Now let's solve the following. Log of x base square root of 5 equals to 4, and log of 32 base 8 equals to x. Now just use the approach we used to solve the examples. So now once you solve, let me have your answer in the comment section. So now we are going to be ending the class now. So tomorrow is going to be another day. We are going to be looking at another aspect of logarithm. I want to believe you have learned one or two things. So don't forget to share this video with your friend and also tap your like button. Thanks for watching.